Mendeleev classified the elements on the basis of the similarity in physical properties and similarity in the formula of their hydrides and oxides. But there were three major limitations in Mendeleev's periodic table. What these limitations are? Number 1, the position of isotopes. Number 2, anomalous position of some pairs of elements. And number 3, the uncertainty in prediction of new elements. And thus, after some time, we get to know that atomic mass is not the correct basis for classification of elements. Therefore, scientists thought that there must be something new, there must be something more fundamental property of elements which can better explain the periodicity in properties of elements. Then, in 1913, Henry Moseley, a young English physicist, showed that the atomic number of an element is a more fundamental property than its atomic mass. Now, we know that atomic number is equal to the number of protons in the nucleus. Thus, atomic number is more fundamental property of elements than atomic mass. So, atomic number was adopted as the basis of classification of elements in the modern periodic table. Accordingly, Mendeleev's periodic law is modified to modern periodic law, which states that the properties of elements are a periodic function of their atomic numbers. This means that when elements are arranged in an increasing order of the atomic numbers, the properties of elements are repeated after certain regular intervals. So, we know that the repetition of properties of elements under certain regular intervals is called periodicity in properties. Now, what is the cause of this periodicity? To learn more, watch this video complete. Hey viewers, this is Devinder Kaur and you all are welcome to my YouTube channel, The Enlightened Room. To know the cause of periodicity, take a look at the table of electronic configurations of the elements of alkali metals. As you can see clearly from this table that the alkali metals have one electron in their respective outermost shells, or you can say the valence shells, and hence have similar chemical properties. You can also take an example of halogens. To know that, take a look at the table of electronic configuration of elements of halogen family. Now here you can see that halogens have 7 electrons in their respective outermost shells, or you can say the valence shells, and have similar chemical properties. So you can conclude that the cause of periodicity in the properties of the elements is the repetition of similar electronic configuration after certain regular intervals. So these regular intervals are 2, 8, 8, 18, 18 and 32, and these are known as magic numbers. So you can say that elements having similar electronic configurations show similar chemical properties. So it could be said that the periodicity in properties of elements is due to periodicity in their outer electronic configurations. Now let's talk about the modern periodic table, or you can also call it as long form of the periodic table. In the modern periodic table, the elements are arranged in the increasing order of their atomic numbers. So this table was prepared by Bohr and is based upon the electronic configuration of elements. Now that's why this modern periodic table is also known as Bohr's table, because this table was actually prepared by Bohr. Now let's talk more about the modern periodic table. Modern periodic table consists of 18 vertical columns which are known as groups and 7 vertical rows which are known as periods. Now these groups are numbered from 1 to 18, and of course the periods are numbered from 1 to 7. Now first we will discuss about the groups and then we will go to the periods. Let's start with the groups. Elements of group 1 and 2 on the left and groups 13 to 18 on the right are called normal, or you can say the representative elements. Elements of group 1 are also called alkali metals, and those of group 2 are known as alkaline earth metals. Now let's talk about the elements from group 13 to 18. The elements of group 13 are considered as boron family. Those of group 14 are considered as carbon family. Those of group 15 are known as nitrogen family, and these elements are famous, or you can say popular, for producing suffocation. Okay. Now the elements of group 16 are known as oxygen family, and these elements are known for ore forming. And the elements of group 17 are known as halogens because they are famous or popular or known for sea salt production. Okay. Now the elements of group 18 are known as inert gases or noble gases, or you can also say, or you can also call them as rare gases of the atmosphere. So there are in all 50 representative elements in the periodic table. Now this was all about the group 1 and 2 and up to group 13 to 18. Now we should also talk about the elements from group 3 to group 12. Now the elements of group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 are called transition elements because their properties lie in between the properties of the elements of group 1 and 2 on the left hand side and those of group 13 to 18 on the right hand side of the periodic table. There are in all 40 transition elements in the periodic table. Now in the long form of periodic table, the elements have been broadly divided into metals and non-metals by a thick zigzag line running diagonally across the periodic table, and you can see it clearly from this table. Okay. Now as you can see, the elements which lie on the left hand side of this zigzag line are known as metals, and those which lie on the right hand side of this zigzag line are known as the non-metals. Now however, there are some elements known as silicon, germanium, arsenic, antimony and tellurium. These lie along the border of this zigzag line, and these elements show the properties of both metals and non-metals, and that's why they are known as semi-metals, or you can say the metalloids. Now let's talk about the periods. The number of elements in any period is fixed by the maximum number of electrons that can be accommodated on that particular shell. You have learned that the maximum number of electrons that can be accommodated in any shell is given by the formula 2n squared, where n is the number of the given shell starting from the nucleus. Now let's talk about the periods. In the first period, you can see two elements are present, which are hydrogen and helium. That means this period starts from hydrogen and ends at helium, and this period is known as the shortest period. Now let's move on to the second period, which has 8 elements with atomic number 3 to 10, and this period starts from lithium and ends at neon, and this period is known as short period. Now let's move on to the third period. The third period also has 8 elements with atomic numbers 11 to 18, that is starting from sodium and ending at argon. This is also known as short period. The maximum number of electrons which can be accommodated in 4th, 5th, 6th and 7th period are 18, 18, 32 and 32. So the 4th period has 18 elements with the atomic numbers 19 to 36, starting with potassium and ending with krypton. This is the long period. And in the 5th period, again there are 18 elements with atomic numbers 37 to 54, starting with rubidium, ending with xenon, and this is also known as long period. Now let's talk about the 6th period. This period contains 32 elements with atomic numbers 55 to 86, starting with cesium and ending at radon. This is the longest period. Now let's talk about the 7th period. It also contains 32 elements starting with francium and ending at Og or UUO, which was discovered in the April 2010. This is another longest period. Now you would all be considered about the another 2 rows at the bottom of this periodic table. So in order to avoid the periodic table becoming too heavy or too lengthy, two series of 14 elements have been placed at the bottom of the periodic table. The first series, having atomic numbers 58 to 71, lying in the 6th period, or you can say the group 3, starts with cerium and ends at lutetium. These elements are collectively known as lanthanides or lanthanoids. They are also known as rare earth elements since they occur very rarely in the Earth's crust. The second series, having atomic numbers 90 to 103, lying in the 7th period and in group 3, starts with thorium and ends at lawrencium. These elements are collectively known as actinides or actinoids. All actinoids are radioactive. So the first three elements, thorium, proactinium and uranium, occur in nature, while the remaining elements or the remaining 11 elements from neptunium to lawrencium have been prepared artificially through nuclear reactions. So these 11 elements are also known as transuranium elements since they follow uranium in the periodic table and have been prepared through nuclear reactions. Okay, both lanthanides and actinides are collectively called as inner transition elements because they form a series with the transition series. They are in all 28 inner transition elements in the periodic table. So the viewers, this was all about modern periodic table. In the next video, we are going to talk about its merits and demerits. So viewers, this was up for today's video. For more videos like this, subscribe to my channel and click on the bell icon. Thank you so much.